So thank you for joining me this afternoon. My name is Marie Candela. I'm a technical product manager with OpenEdge and from the Burlington office in the US. My presentation this afternoon is about 12.8 focused on the database area. I've been with Progress for almost 18 years now, and I originally joined them to be development manager for the database team. And when we changed how we do our development work, I moved into release management. And I've been with the product management team now for a couple of years, but I've maintained my focus on the data management database area for all of that time. My presentation today, while it's about 12.8, 12.8 is the LTS after a series of the innovation releases from 12.3 through 12.7. So I'm going to go through features that if you've been paying attention to the innovation releases, you'll say, hey, I saw that before. If you're more the type that's really just staying with the long-term support releases, or if you're even still on 11, this is all new to you anyways. Because I'm doing a range of releases here, I've got several features. This is not going to be a deep dive. My purpose today for this presentation is for you to see something that you're interested in, that you want to know more about. So there's not a deep level of detail here. We can have further conversations later with the detail. This slide may look familiar to you if you've been coming to PUGs regularly and seeing roadmap presentations. It's our themes for the 12 series of releases. And we've been using these themes for a number of years now. The database features tend to fall into these specific areas. Often an individual feature will actually contribute to more than one area, but in general, this is where our work comes. First, I'm going to go through performance enhancements. There's a number of types of enhancements here. Some of them are enhancements that you would want to tune in order to perfectly balance them for your system and your needs. And in fact, some of those you may not even choose to use. So they'll have some parameters for configuring them on the command lines. There's others that contribute that they're just things that we found either through ideas or bugs that we found that the algorithms had a little waste in them, and so we've just improved those algorithms, but there's no tuning for you to do. And so you'll see as we go through the slides which is which. The other thing is that from a performance perspective, well, throughout 12, we've been really focused on reducing downtime for the database or for your system in general. And one of the things that I learned in the survey from a couple years ago, if you filled it out, I asked a lot of questions about, do you have planned outages? If yes, what are you doing during those planned outages? Have you had an unplanned outage, a database down in the last year or so? What did you have to do to be able to get it back up? And then the third question was, do you do any kind of regular little h, little c, health checks? Are you doing something almost continuously or periodically for the health and the maintenance of your system? If so, what are you doing? What I was, I guess surprised to learn was that for all three questions, the answers were very similar. You're all doing about the same thing. It's just varying on whether it's planned maintenance, a planned outage, or if something just got out of whack and that's it, the database went down, and you have to do that then. So we focused on, and the health check items were also similar. So we focused on those utilities, that kind of maintenance work that you were doing on either if they could only be done offline, bringing them online, and then also trying to reduce how long that they took. So that's why there's a lot of things listed here in performance. I'm going to start with backup and restore. It's a critical operation. It's part of your disaster recovery. You may or may not use our backup and restore. There's other approaches to it. But if you are using OpenEdge's backup and restore, what we have found, well, first off, what is backup? It takes the database blocks, makes a duplication of those, puts them in a backup file. Restore does the mirror image, takes it out of the backup file, puts it into a database. However, they're CPU-intensive operations, and so they spend significant time in your disk I/O, compressing and decompressing the blocks, and also with the CRC check and restore to ensure integrity. And so when the team did analysis on how are we spending our time in these operations, they found that we could spend up to 90% of the time just in those three areas. So what we did is we looked at threading it, and we looked for opportunities within the process for the threading. Similar opportunities exist in restore. So what we did is we cache read and write buffers to minimize the disk I/O and to improve concurrency. And we've made several things happen in parallel now. Buffer transfer operations, compression and decompression. In restore, we made that CRC check happen in parallel, and we've added asynchronous disk I/O. Pardon me?
Online or offline? Is it for both? Online or offline?
Online, and I think that's on the next slide. So, the threading availability is only on backup online in 12.8. That does not mean it will always only be online. It's just where the release happened to fall with the work. For restore, so it's online, your users can stay connected, and with restore, you can use full or incremental backups to do that restore, and it also works with the no verify. You'll see on the right there, we've added several options for managing your threads. You can turn it off or on. It is default to off in 12.8. I have to check because different utilities are in a different place. You can specify the number of threads. If you do not, it will default to 6 CPUs. Actually, yes, and if you have fewer than 6, then of course it'll default to the lower number. And then we've put in some parameters for managing these buffers to be doing some of the work in parallel. Now, back to the number 2 problem with our area of performance for backup and restore is the compression and decompression. We've had for several years now, well, probably forever, our compression algorithm was an RLE algorithm, which is not terribly efficient. And so what we've done is incorporated a third-party Z standard algorithm for compression. And when we did that, we also had to add another parameter. So there's always been -com to do the compression. We added -com level. That parameter gives you flexibility between 4 different levels, one of them being the legacy RLE algorithm. And then we've got 3 different levels that we've identified with the Z standard algorithm. One is emphasizes speed, which is less compression. The other is the other extreme. You get more compression, but it's going to take longer. You just have to do the work. And then we chose one that's a balance in between the 2. Now, which version? 12.5, I believe, is when we changed our default compression algorithm to be the Z standard, the middle one. So if you're coming from anything prior to 12.5 to 12.8, this ability will be there. This is for both online and offline backups. And we found that not only is it improving your performance for backup, it's also improving your performance for restore. And then the third item that we had in big ticket time for backup and restore was the CRC in the restore process. It spends a significant amount of time because it's going through and recalculating checksums and then comparing them to what's been stored in the database in the data block header. What we've done is implemented a no verify option, which will enable you to skip the CRC check. Now, when the developers proposed this, I sort of like integrity in my database and in my data. I don't really want to skip a check. But the approach that we have proposed is that instead of doing that check at the time that you're doing the restore, you have the ability to do a partial verify on the backup file right after you've created that file. So it's on the pro restore command, but you do it on the backup file after you've done the backup. So you've verified that integrity in that file, put it on the shelf, and you don't have to have that verification redone when you actually go to use it, if you ever have to. The partial verify does not actually do a restore to the database. It's just doing that verification. And so you can do that separately and standalone. And if you use it after each backup is created, what you've done is you've put a little more parallelism yourself into your process of getting your backup files and when you actually need to restore them. I do need to warn you, that last line on the bottom is important. If your partial verify indicates that you have a CRC problem, do not do a restore with no verify on that database, because you'll just be putting a problem in. Okay, that's it for backup and restore. Now we're going to go to index utilities. I'm going to start with index check. This is our second most frequently used utility. It's used in all kinds of situations. Again, as I mentioned earlier, if you're doing some periodic maintenance, just wanting to make sure that your database is in good health, or you could have a database down situation. So we've added threading to index check. What it does is it goes through, and actually the different options work in a different way, but it goes through and it compares index key entries and the index keys against the records. It can take very long time to execute, and we've had anecdotal reports that like a terabyte database can take up to a month to run index check on. So we're very interested in getting this to take a shorter period of time. So the enhancement we made is to add the threading techniques. It's available for online in 12.8, online only, index check for options 2, 3, and 4. And as I mentioned a second ago, the threading model is different depending on what we're checking. So on options 3 and 4, it's a key entry focused model. And so what we do, here's your index block depiction, where you start with a root block. That will go down to non-leaf blocks. And again, this depends on how much data you've got, how much activity the index has, etc. And then you'll eventually end up at a leaf block. We call these the levels. Some of our indexes can get to 4 or 5 levels if they're very, very heavily used. In your root block is where you have the key entries. And what we do is so we progress down with the key entries and go down through the blocks, and eventually you end up at the bottom. At your leaf block, you get a key with a row ID where you're going to go to the table and do that validation. The threading is applied at the key entry level in the root block. So this is where we can get some parallelism in as we're going through and doing our validations. Now, if you specify more threads than you have for entries in the root block, then it's going to go down to the number of entries in your root block. Now, the opposite approach is the record-centric model. So this is a type 2 data area. Keep in mind, it's got to be type 2. We've got data blocks in there. They contain records. So how the validation works, again, this is option 2 for index check. How the validation works is that we'll read the data block, the next data block in the area, and then it will extract the record from the data block and build the index keys fresh. And then it will search for those keys in the index, and that's how we get the cross-validation. The threads in this model operate on your different data blocks in your area, and so they just keep walking through until they get all done. The availability on index check, again, remember it's online index check. It's not an offline index check in 12.8. It's for options 2, 3, and 4. Threads are not spawned if you have a word index. If you're very small table objects on option 2, or if you have small index trees on options 3 and 4. What you get is when you have that small, you can't really squeeze any benefit out of it. Now we're going to go to index fix. On index fix, I believe we have this on 2 areas also. First is record scanning. That's options 1 and 8. So what they do is they scan the records looking for missing or incorrect index entries, and they do the index block validation. Our challenge with index fix is that it will scan the area. It's basically doing a brute force walking through and scanning everything. So you see the red arrows pop up. We're going from block to block to block to block. And that's not necessarily, we found a better way to do it. Because we're in type 2 areas, that gives us a cluster link. And what we now do is follow the cluster link to go down. And you can see in the bottom there, on the bottom right, we have much less red, much fewer blocks that we're having to traverse and then do that validation against. So you have a performance improvement there. This is one of those that you don't have to turn on or off. There's no tuning for it. You're just getting this for free. Just wanted to let you know. Here's the other index fix option 2, where this does index scanning. And so this is another one of those that just like the other. This one you don't have to do anything for. It's in there. But the challenge was that the process is locking all of the tables for each index key. And therefore, when we commit the transaction, it's an expensive commit, as it's generating a lot of latch activity. So the enhancement that we put in is to reduce the number of transactions that are required in the index scan. And so that then will reduce the number of commits and the number of latches that are being exercised. This applies when you're doing scanning of all tables and with all or many indexes. Again, if you're only doing maybe one index in a table, you're not going to see the improvement. But it's when we start getting up to the volume that you will see that parallelism. Next, we go to index compact. Is Patrice in here? No. Okay, this is the index delete chain. Patrice is very interested in this. So unique indexes have special treatment in that when they are deleted, they don't actually go away. We start by putting a delete entry in an index block, and when that block is full of delete entries, that goes up on a delete chain. The delete chain can get long, and it does get traversed. Now, the challenge that we had is that there was no easy way to clean that out. It would happen, let's make sure I got the right one. Right. The cleanup of the unused blocks on the delete chain would happen sort of a byproduct of another operation, like a create or an update or index build. So we've been asked several times to give you a way to do this, because this will become problematic, like when you've done a mass delete. So Index Compact has 3 phases, and it turns out that the first phase of Index Compact actually goes through and cleans up this delete chain. So what we did is we've given you another parameter on Index Compact, unused blocks. And so what that'll do is it'll just do phase 1 of Index Compact, and then it'll stop. So that way you're not having to deal with a full Index Compact, but you are getting your delete chain cleaned up. Okay, Index Activate. It's actually two little things we did here in Index Activate. The first is that we had observed that the underscore file table was being read for every single record that Index Activate touches. That's a lot. The thing is that underscore file rarely changes. So we said, okay, we'll read it once at the beginning, we'll put it in the cache, and then we don't have to keep going back and reading that table again. We just take it from the cache. The second issue that we saw in there was that it was also wasteful when it was inserting index entries, and that it was going ahead and doing a check to say, is this entry already in here? Oh, okay, now I'll insert it. The thing is that the index manager could already handle if we had duplicate entries, so there was no harm done that if you tried to put the duplicate entry in, so we just stopped doing it. But these things gave us performance improvements. Okay, this is it for indexes. Now we're going to go to space, or cleaning up your space. So there's things in this area: record fragmentation, cleaning out a table, returning space to the OS, and managing BI growth. Again, just like with the performance, there was a major focus on being able to do this online. These are some of the activities that people would be doing when they had an outage, planned or unplanned. And so our goal was to move this activity to be an online activity, and you wouldn't have to take an outage. So here's your challenge. I mean, you all know this. I know you all know this. When the database is created and the records are loaded, everything's nice and neat and orderly, and they're sequential, and it's easy to traverse, and everything is just wonderful. And then over time, we have records that are fragmented. They go into other, they split between blocks. There's holes that stuff gets deleted, and so we lose all that nice, orderly, easy to traverse stuff. Now, we've had existing options to be able to deal with this. One is that you could do a dump and load. However, you were going to have to restrict access to your table and indexes, which means things can't be used at that time. Or you could have used the table move utility, and that would double your space because you now have 2 copies of that table. So what we've done is we made a table reorg. It's online again. It only works on type 2 storage areas. You will specify which index to use to order your table. If you don't specify it, it will default to the primary. And what it does is, as it's reorganizing, we have avoided the doubling the size of the space by reusing a cluster. So we'll have one cluster go away. We have it, that space from that cluster is reused as we progress through it. What that does, gets us all back to our neat and orderly table again. So your scatter factor is reduced. There's no longer a need to do a dump and load. You can ignore or you can improve your application performance now because things can scan more quickly. And you've managed to do this without taking your database down. We have added 3 ways that you can optimize your table reorg. The first is the ability to cancel and resume it. So as it progresses, it's working its way through the clusters, et cetera, and you might cancel it. And then when you start it the next time, add the keyword resume on that command line, and it'll scan up until the point where it stopped, and then it will start the reorganization process again. The next possibility is restrict, which is restricting the scope of where you're doing that reorganization. So you have an upper and lower indicator, and you'll just do it within that area instead of having to do the whole thing. It may be that you want to parcel it out and do it a piece at a time, or one every weekend or something, or you may just have a particularly bad area that would benefit from cleaning up instead of doing the whole thing at this time. If you do not put restrict on the command line, it will do the whole table. And then the third one was smarter scanning. And so you may find, depending on the lifespan of this table or et cetera, there may be known areas in there that are already clean and in order, and they don't even need to be included as part of the process. So the smart scanning will start and go, and it'll look and say, hey, do we need to reorg and do that reorg activity right now, or do I just hop over this? And it'll proceed up until the point where it sees an area that does need to be reorganized, and that's when it will start doing the reorg activity. What this does is it improves your performance a bit if your data is in this kind of pattern. Okay, next is table truncation. So the issue is with table truncate that as time goes by, you'll probably have some data in there that you no longer need. It's either really old, you've archived it off, it's time to get it out of my database. It could be CRC data from the tracking that we've done of changes. It can be key event data. It doesn't matter what kind of data it is, you've got extra data in there, and it's taking up space, and it's also probably getting caught up in some queries or something, so it's costing you time, space, and performance. So there, I do have it. Your existing options are that you could do a table drop, which requires the exclusive DB access and invalidates the R code. That sounds messy and ugly and undesirable. You could also do a record delete by the client. If you do that with the clients coming into the database to do it, it's going to scale linearly. So as you have more, it's just going to keep ticking that same amount of time, more times, longer. That also, if you're doing it concurrently while the database is online, you're going to introduce contention with your clients, with your active OLTP work. And by the way, that does not return the storage to the area. So what table truncate does, well, it's the table move command. Note, it's online. So it's a table move command. We've added the truncate option to it. And so it will allow you to truncate in place. You can either leave it in the same storage area, or you can move your material out to a different storage area in this command. It'll make the storage space that was previously belonging to this storage area reserved to it. It's now available for reuse within the area. It stays within the area. Because it's online, your active applications continue running. The tables and the lobs must be in type 2 storage areas to do this. And it does not excessively grow the BI file. It's not setting off a number of transactions and commits. It's very quick. Remember, we're in a type 2 storage area, so we're working at the cluster level. And what that actually means is because we're working down the cluster chain, we're not going to get it, it's not going to scale as you're doing more. It scales flat, which means no scale. It's also very quick, relatively, as an operation. It's recoverable, and the changes will also be replicated to your replication targets. So what this does, it's the closest thing to being able to do a table drop without affecting your R code and your CRCs. You'll be able to remove database objects, tables, indexes, and lobs relatively quickly, return the storage to the storage area for reuse by other objects, and also avoid your downtime. Then we start looking at areas. We have an online area truncation. Right now, or prior to this feature, the area truncate operation was offline only. It required the AI to be disabled and also to truncate the BI. And it forces replication to be rebased. Your target had to be rebased. Again, another very ugly and expensive operation. So what we've done, we've put it online. We did this by way of enhancing the pro-util truncate area. I believe we added an online option to that. Or maybe it just works now online. It will work. It will now work with all of the ugly, without the ugly things that were there before. So it'll work with your AI enabled. It works with replication. It works with both type 1 and type 2 storage areas. It just was, type 1 was right in there, easy to do the same way as the type 2. It works with pub and non-pub tables. So your schema is preserved. Your area high watermark is reduced in this. And so all of your area objects are also reset. There's no RM chain or index delete chain affecting a truncated object. Now, your prerequisite to do this is that you have to have cleaned out, done your previous command. Your area needs to be empty of objects. And then finally, we have online area removal. So the ProStruct remove utility removes extents from the storage areas, and when it removes the last extent, it removes the whole storage area. The problem was it was available only when the database was offline. So therefore, you needed to have a maintenance outage in order to return space to the OS. So what we did is we made it online. It works, again, same kind of list as the previous one. It works with replication. It works with type 1 and type 2 storage areas. It is only for data storage areas. And it works with fixed and variable extent types. Now, your prerequisite is that your area must be empty of storage objects and truncated, which was the previous enhancement that we just talked about. So what this does, this is really what we were looking for, was our goal was to enable you to return storage back to the OS. So we put these three together. You truncate your table, you truncate your storage area, and then you remove the storage area. You could do all of this online, and you also can do the parts, the individual parts at different times. So you can do it when it fits in for you, and we looked at this not only from a performance and online perspective, but also keeping in mind that those of you that are in the cloud, that are in essence leasing space, that this will give you the ability to more dynamically respond to space needs when you actually don't need as much. You can return it back. Okay, I see I'm running a little long here, so I'm going to try and go a little faster. So this is the BI file. And most of you, I think, have either experienced or heard of situations where if you have a long-running transaction, and if you especially have a long-running transaction that's easy to be interrupted, not interrupted, but paused. Someone's filling out a form, and they get up and they go to lunch. And that long-running transaction is sitting right there, waiting for them to come back from lunch. Now, in the meantime, in your BI file, we see we've got the active transaction is the red, and the committed transactions that have already completed and are committed, are the green. Now, theoretically, you could get rid of those green ones, but that red one is holding up that activity. We're running out of BI file space. We have to go get more. And your BI file just keeps growing and growing and growing. Now, the thing is that the only way that you can really take care of this is to shut down your database and truncate the BI. So we've given you something that will let you manage this better and stay online. We created a daemon. It's a process called Before Image Manager Process, or ProBIM. What it does is it goes out, it's garbage collecting. It's going out to see what are all of the green ones, and it removes those, makes that space available within your file so that your red one can keep doing what it needs to do. It will make your BI less variable in how it grows if you're susceptible to that. It has a parameter for scan time, and it's a frequency, so how often is it going to go out? We set it from a 1 to 10. The more often it goes out, the more often it's collecting. You should have less variability in that file, less opportunity for growth. What we recommend, we've saw from this that there was an up to 9% or approximately 9% performance gain in your transactions, especially in the case of the long idle transactions. We did not see a noticeable resource overhead from the ProBIM. And of course, so your smaller BI scan time, that's actually a duration between scans. So that will happen more frequently. It'll keep it less dynamic. What we recommend is that you set this, set the default to 10 seconds, the upper limit. See if it's doing anything for you. If you're still seeing growth, drop it down a bit until you see an area, again, that works just right for you. All right, that's it for space management. I'm going to touch base just for a minute on security. Is there anyone in here using an HSM in their environment? Anybody? Okay, and then I'm just going to briefly mention it because it's a kind of thing where you're not specifically doing it for the database. It's usually larger in your IT organization. It's another level of security. H stands for hardware. It's a hardware security module. What's interesting is, like a lot of things in IT, even though it started as hardware, it also comes as software. So it can be present in your environment in any number of ways. It's an enhancement to TDE if you're using encryption. And what it does is it'll give you another level of security for your key store. That's all I'm going to say about that. That became available, I'm thinking about 4 or 5, so it's been out for a bit. But it's the kind of thing where either you need it or you don't need it. The other area in security that we were active in database was this dynamic data masking feature. It's really a client feature, and you should have seen, I don't know where his session is in relation to this, but if it hasn't happened yet, you can see a lot more detail on it. The database participates in that you enable or disable that ability on the database, and there's also storage of role definitions, etc. That's the fastest I've ever gone through security. There's usually a lot more to say. Now I'm going to do a handful of items that are ease of use, and these also tend to be things that either you have this issue or you don't. It's not like a feature that you'll want to pick up. The first couple are about something where I have called database addition skew. Some of you may be in this situation where your production database, large, you need an enterprise license on that. You need all the tuning that you can do at the enterprise level. You need the additional features, etc. But you may have a copy of it back in your development QA environment, and you only license that at a work group level, which is all you need there. But there's a few things that happen because you've got that dynamic. Is there anybody in here that's in this situation where you've got this? Okay, I saw no hands. Large file support pops up with this because it's an enterprise level. Guess what? Large file support, that's really sort of, old in technology. Everybody does large file support. You don't need to enable it anymore. What we did is we made it the default. So now you're no longer running into a problem in your work group environment if your extent got larger than 2 gig. I'm going to move right on. The CDC-enabled database. Anybody using CDC or Pro 2? There we go, because that Pro 2 brings along CDC with it. So this is another one. CDC is an enterprise-level product, so you may have that on your production database. The problem is, it's very interesting. So if I take a backup and go to put that in my work group environment, I can't, when I restore that backup, I can't bring that database up because it doesn't have a CDC license in that environment. In order to disable CDC, I need to have the policies removed. But I can't remove the policies because I can't run CDC in the workgroup environment. So what we did is we've given you 2 more commands, a deactivate CDC and activate CDC. The deactivate, you don't need any CDC license for. You run that in your workgroup environment. And then you don't have to do any purging, you don't have to remove the policies, you're just deactivating the CDC. So it'll stop the writes that from the client activity. And then clients can still access the data, but you're not capturing the changes anymore. Then we take the activate one. I'm not quite sure why we'd want to go in the other direction, but just in case, you can turn CDC back on, but this one, you do need to have the license because you're running CDC again. And all your rights will be resumed. Both of these, this is both your online and offline environments. There's no taking the database down for this. AI Archiver. Enabling AI Archiver prior to our enhancement could be done in 2 different ways. So one was we had an RFUtil enable AI Archiver command, but that had to be run offline. So it had to have your database down. The other is there was an extension on Pro Backup that on the end, it would, by the way, enable the AI Archiver. The problem is you have to go through a whole backup to do that. Now, even if you don't create the backup file, it still goes through the whole backup process. So we wanted to decouple those 2 things, enabling AI and doing the backup. So our enhancement is that we enhanced the RFUtil AI Archiver command to be able to be done online and also to support all of the options that already existed on the Pro Backup online with respect to AI archiving. Is anybody going to find this useful? Okay, couple of heads nodding. All right, I believe this came out of ideas. Somebody was frustrated. Maybe many of you were frustrated. Okay, I think this is the last item I have here, the backup file. So this also came out of ideas. There was this entry about, we need anything that will help us identify what version of the backup file we've got. Somebody had a version 9 backup file, but they were needing to find the right version of OpenEdge to be able to make use of it. Apparently, they had to make a number of attempts. So we said, well, we don't really have a good way to see what's in that backup file, so we made this backup describe command. It works on full and incremental backups, and what I think the real goodie is, it works on backups starting from version 9 forward. And this is a sample output of it. You can see this became available in 12.5. Lots of information in here, where the file came from, platform, Indian, all kinds of things. Oh, shoot. How am I doing on time? Have I got a problem yet? Okay. This is for the convert 11.12. This is when you're upgrading from 11 to 12 with your replication. You have replication, you have a replication target. The previous and the challenge and the time-consuming activity was you would first convert your source database, and then you would have to go do the basically baseline your targets. You'd have to go do the backup and get it restored, get your targets set up. This could be expensive time-wise, especially if you're like trying to do a minimal outage to just cut over to the new release. So what we've done is we've enhanced Convert 11.12 so that if you're in a replication scenario, you can actually do that convert in 2 parts. So first, you would convert your source database, and you would use, first you're going to synchronize, so you get everything synchronized where it belongs. Then you convert your source database with an additional parameter on there, REPL source. So it's telling you to convert, we're doing a source database, and it's going to output as part of that converse another backup file, a schema area backup file. Then you will go run the convert on your target database. Remember, it's synchronized, but your target stayed in 11. You'll run a convert on the target database, and it will consume that schema backup file. And it will also make some adjustments in the master block so that it's ready for synchronization. Now, both of them had, both source and target had been converted to 12. The last step you have to take is run a synchronize again, so that now your target and source are in sync and replication is ready to go. I do have a note here on this because I know some people are in this situation where you've got user tables in your schema area. And so this will reduce the benefit of this enhancement. I don't know how many are still in that situation today. And that was my last feature. I hope, can you give me a show of hands? Did you find things? I saw people taking notes. I saw heads nodding. Find things that were interesting here? Thank you. That's good news. So I give you references. There's plenty of more information in various places. Be sure and check the compatibility guide, and also the bottom item. The clock is ticking on 11/7. I know you've been hearing that a lot. And then this is a link to, we had a hard copy handout at the Progress Desk, but this is things like your link to your OpenEdge OpenEdge survey that just came out Tuesday. If you haven't done that or received an email with a link, this is your way to get one. And several other materials. There's community activities on this, how to become OpenEdge 12 certified for free, etc. Questions? Yes?
I just wanted to ask, I saw earlier when you were talking about the new options on the -com on the backup for the compression. Does that take into consideration the stuff with TDE? Because once you get TDE on your database, then those blocks are encrypted. You can't always see what it contains, so it always also backs up the empty blocks. Has that been built into the new -com options to exclude those empty blocks?
I'm sorry, I'm going to make you go through some of that again, because I didn't hear the beginning.
Yeah. The minus com option for the backups, for the compression.
Oh, the compression with the TDE. Yeah, that's a problem with encryption. See, with encryption, what you're doing is you're removing patterns from the data, so people can't recognize them, or machines can't recognize them. So compression doesn't really do much on that. There's not a lot that compression can do.
So when the backup agent reads the data, you can't decrypt it and only backup valid data, not into space. Because now we've got a... No, but even if you have a lot of empty space, and because I'm Apple TDE, it's not compressing. My database is 1 terabyte, it backs 1 terabyte. If I turn TDE off, it backs at 700 gigs. Because there's all those empty blocks of it now. So the TDE...
When you have all TDE, then it will find the patterns to compress. So if you add the TDE,
yeah, but that's what I'm asking, the minus com options.
That's not going to affect that challenge. And that's a nature of encryption. It's not for backup to go in and say, oh, I've got encryption here. There's nothing we're doing to withhold it. Yeah. It's just a nature of what now is in there.
I have a customer,
Do you want to talk on my headset?
that some people are not using application, they are using AI, they cook AI.
Yeah.
And the good thing was, you can compress them quite nicely. But that customer made a TDE, and now
that's it. They lost it. Yes. Yes. That's it. That's the challenge with if you're using TDE, you're not going to get the benefit of compressions. Yes. Other questions? Because I've turned my back on some of you. I'm sorry. It's just you're so far away when I stand up there. Anything else? Okay. Then thank you so much for coming.